Greetings, folks. There's a subtle difference between graphing things in a math class and graphing things in a physics class. This video is going to take a look at that difference. So let's say you're into commodities, beans for instance, and you go to your bean dealer and you want prices. So your bean dealer hands you a graph, and the independent variable in the graph is the number of bags of beans you're going to buy. And the dependent variable is going to tell you how much you're going to pay. So here is the graph. Here is the function that defines the graph. Two different ways of figuring out how much it's going to cost you. One is to move along the x-axis until you identify how many bags of beans you want. You go up to your graph, you go across until you hit the y-axis, and you read off the y-axis how many dollars that number of bags is going to cost. Second way to do it is to take the number of bags, which is what the x variable is, multiply it by the slope of the function, which in this case is how much it costs per bag, 40 cents per bag, add it onto the y-intercept. In this particular example, the y-intercept is the commission. It's how much you're going to have to pay above and beyond the cost of the bags of beans, to be able to make the sale. You add it all up and you have your total cost. Two different ways of figuring out how much it'll cost. So you've seen how that graph was used in a typical math problem. Now let's take a look at a physics problem. Consider a dragster. Its position changes as a function of time, so its independent variable, which is to say the variable that's graphed along the horizontal axis, will be time, and the dependent variable, the one that will depend on time, will be position. So once again, here is the graph, here is the function. If you want to know where the body is at some point in time, you have two ways of figuring it out. You can either move along the time axis until you identify the point in time you're interested in, go up to the graph, go across to the vertical axis, and read what the coordinate position is at that point in time in meters. Or you can put the time of interest in for your variable t, multiply it by the velocity, which is the rate at which you're traveling per unit time. In this case, it's apparently 0.4 meters per second. Add that onto the offset, which is associated with where the body is at t equal to 0 seconds. Okay, apparently it was at 6 meters here. Add all that up and it will tell you where the body was at that point in time. The bottom line is that there's nothing magical about the variable x. It doesn't have a lock on the horizontal axis. You have associated it with that axis in your math classes, but you've done that for convenience sake. There is no set-in-stone precedent here. In fact, in physics classes, the horizontal axis will often be associated with the time variable. Anyway, that's it.